Hey guys, I made a little something a while ago. I was studying a little bit of artificial intelligence, mainly pathfinding algorithms, and I decided to make a little something of my own. I created a navigation system of Busch campus. Basically, what that is, it's a mock version of Google Maps on a smaller scale. By typing in a starting location and a final destination, the program will generate an optimal and the shortest path and guide you to your location in an efficient amount of time. Okay, so let's get started. Alright, so you begin by typing in your starting location and your final destination. So we will type in abbreviations for this. So for example, let's try out Richardson Apartments to Busch Campus Center. And as you can see here, two things pop up. Let's discuss this first. Okay, so you should know that there are two paths. There's the walking route and the bus route. The walking route is basically you going from one location to another location completely on foot. The other location is walking from one place to other while also using the bus. So basically bus route, it's you taking the bus and then walking the rest of the way. Okay, so you can see here that these are the directions. Directions are from one location to another. So you at the Richardson Apartments, you go to like 14, which is actually like an intersection, and you go to the bus stop at the Library of Science, and then you go like all the way until like the Biomedical Engineering Building, Busch Suites, and BCC. The bus route, basically you go from RIA, you go from Node, you take the bus route, go all the way to the BCC bus center, and you be dropped off at BCC. And okay, so there's also information below. The destination is mentioned as well as the estimated time. And you should note for the bus information, for the timing, it does not take into account the waiting time or the fact that the bus stops for every few seconds at every bus stop. So generally, this will be longer. Okay, now I will mention the second part of the graph. And basically what this is, it's a map of Busch campus, and it's basically a visual representation. So as you can notice, the cyan path is actually the bus route, while the dark blue path is the walking path. And basically what I had to do is I had to actually take a map and individually measure the distance. And from that information, I had to like translate into that data into something the computer can understand, more specifically a unweighted graph data structure. And basically the program knows every single distance in between every single place. So with that information, it's able to calculate the shortest and the most time efficient route. And as you can see here, you can like see the little places. For example, the Hill Center, the Physics Lecture Hall, BCC, the Hill Center bus stop, and all that kind of stuff. Okay, so let's try a different example. Okay. Okay, now let's try the Library of Science and Medicine to the Electrical Engineering Building. And as you can see here, this is a path generated, and it compares the bus route to the walking route and see which one's more efficient. So from LSM, you would go to the ARC, and then the ARC bus station, then the nanophysics laboratory, then the circ, and past the engineering building, and it would arrive at the electrical engineering building, as opposed to the bus route, which would be to travel to the Library of Science and Medicine bus stop, drive all the way to the Hill Center bus stop, and then you would get off from there. Let's try another example. Hill Center to the BCC. And as you can notice, generally when you want to walk to the host center in the BCC, it's generally a lot more time efficient to actually just simply walk there, and this program recognizes that. While walking, the dark blue path knows that basically this is the most efficient pathway to go to the BCC. So does the sign and the bus path. Basically, this program recognizes that there's no point in taking the bus. You might as well just walk from the Hill Center to BCC. Therefore, it's not suggesting any bus routes. Let's try another example. Let's go with the let's go with the Hill Center bus stop to the BCC. And as you can notice, these are the paths generated. While walking would be going here past the engineering building and like that. Interesting enough, applying the most efficient bus path is to take the College Avenue bus, go to the Weveland Recreation Center bus stop, and then get off from there and take another bus stop all the way to BCC. As you can notice, this program is not perfect because there's one thing that this program does, and it ignores ignores waiting time for the bus. And the thing about that is that it's difficult to predict the time you have to wait. For example, in daytime it's like 3 minutes to wait for a bus. At night, like late at night, it's like 30 minutes. So it was not taken into account because the timing varies, and it was hard to put into this algorithm, and therefore this program, as opposed to choosing this bus path, which is just basically just taking a one-way bus without any transfers, it suggests this as if that we can just hop off one bus and then go hop onto the other without any effort, as in as soon as we go to a bus stop, there's already a bus waiting for us and we don't have to wait. So I'm going to take into account of that later on as I work on this. But overall the program works. It's able to generate a path. It's able to recognize on how to get from point A to point B. Walking path is completely optimal. The bus path needs a little bit work, but overall it's pretty good. Let's try another example from the ARC to BEST. And this is a path generated. We see the walking path would be here, bus path would be here, stuff like that. And let's try the CERN, which is that physics department building, and Busch Suites. So the bus path recognizes that you have to go up north in order to reach Busch Suites quicker, while the walking path, it goes cuts through until it goes to the circ, then the biomedical engineering building. It finally arrives at Busch Suites. Okay, and I take a look in time. So the walking path, it will take like an estimate of 4 minutes and 50 seconds, and the bus path is like 4 minutes and around 30 seconds. Remember, this does not take into account of waiting time and the fact that it has to make a stop at every bus stop. So generally, it would be estimated to be a bit higher. So so the next time you happen to walk out of the physics building, the CERN building, and want to go to Busch Suites for whatever reason, you now know that it's better to walk instead of taking the bus. Okay, so that's all I have to show you for today. So this is basically the navigation system of Busch campus. It's basically like Google Maps on a smaller scale. It acts just like Google Maps, only well, just like I said, at a smaller scale. Like, not streets or cities or anything, but basically like in virtual campuses, which I don't think Google Maps can even do. Uh, and one interesting part of this is that basically, if this has the ability to track user location, this could be a GPS. So could this be a potential or GPS someday? Well, I was thinking in the future that I could try to make a Rutgers GPS on the mobile phone, basically a mobile app. But that'll be in the late future. I have like my own projects, and I may eventually get to that in my free time. But this is what I have to present to you today. All right, all right. This will be useful for those who can navigate Busch campus well. Basically, like me when I was like doing my first semester, where I was like a Livingston student and had to like get used to the Busch buildings there are, and overall navigation of Busch campus. In fact, when I was doing this project, I discovered a lot of Busch buildings that I never even heard of. So this would generally be useful. Obviously, this application is not useful right now, but it may be useful in the future if more advanced features can be implemented, such as tracking user position. Alright, well, that's all for today. Okay, this is Sir L. Loher signing out.